Hey everybody. So I'm going to get started since my clock has started and I've already lost 20 seconds of this precious time. So I'm Rich Hurry. I'm the president and founder, one of the founders of Kitestring, and we're developing a product called Ozone Rig Studio, which allows us to bring feature quality deformations into runtime. The real truth is the goal is to build a system where you rig your character once and you can animate it anywhere you want. So not just Unreal, but everywhere, though we all kind of know where it's all heading, right? So the, the key was to be able to bring a different way of thinking about deformations and have that running in the environment you want to work in, and especially in real time. We knew that was big for us. A couple of shout outs just right out of the gate. I wanted to thank AMD, a partner who's been helping us with a short film that we've been working on, and as well as help development of our product. I've got a Threadripper here, and it's fantastic and awesome and the best computer I've ever used, which if you ever get your hands on one, you should do it. And also thank Epic. They have been a big supporter of what we're doing. So I'm gonna dig right in. If you go, we have a website, ozonerestudio.com. You can request a demo, check things out from there if you're interested. All right, so let's go into the demo. So the first thing I want to show here is a little character we built. This is Zoe. And the key, the first takeaway, is that what you're looking at is not an Alembic hash, right? What you're looking at is live deformers, deforming live in engine, using our Ozone engine powering it. And to kind of make that point, I'm going to go here, I'm going to turn this to wireframe, and show you that we have real-time subdivision surfaces. So now we can, on the fly, change our sub-D level, which gives us the ability, and let's pause this for dramatic effect, right? This allows me as a rigging TD to rig that many points, but in real time, be able to animate that many points. So right at the beginning, we're solving what we feel is a really big problem with trying to bring that kind of feature, television broadcast, film mindset into games, which is I want to work on a subdivision surface cage so I have less points to manage and then let the machine do the work to give me the smooth final results. So this is all happening live and in real time. Another point to make here, which I'll show off a little bit more in another character, is there are no joints or blend shapes in this face rig. What you're seeing is a series of layered deformers put together to create these shapes. Okay? Now to kind of bring that here, we're going to run over to this guy. So we have this little character here, little mushroom puppy. This is part of a story we're telling. Our director is Rowena Fresnel. She's an amazing character sculptor artist. Find her on LinkedIn or Twitter if you're interested. So we're bringing one of her little worlds to life. And this character was animated in Maya, and then we sent the animation data into Unreal. So we have as a clip format that contains just the animation data. So what this means is this animation, right, as an Alembic, is like 260 megabytes for just this one character for this 30-second piece. The animation clip is like 100K, right? So that means that from a studio perspective, the workflow of being able to work in, say, a legacy system like Maya, animate like you're used to, and then get all the power of the real-time rendering in Unreal, this sort of unlocks that and also creates a much, much smaller data pack that you've got to be sending between artists. It's like 95% smaller. So it really helps on the IT side too. So looking at this, the way we structured it is we have a blueprint here that holds basically the Ozone actor information, and then we have the rig, and then we have the animation clip. And what's nice about this setup is that you can be swapping the rig out and not change your animation. You can swap the animation out and not change your rig. So it's just, even at this base level, we're trying to think about how artists really have to do work in real time, or not even in real time, just in real production, which is constant revision, constant updating, and this makes that a lot easier. Now, we'll come here, and so this little character here, I'm driving it in Maya. Now what we're using an off-the-shelf, open-source Puppet framework called mGear to drive the Ozone deformation system. And the way this works a little bit, let me open up our node view. So is that we have a single node in here, and this works the same way, the way I'm showing it to you in Maya, also the same way it works in Unreal, which is all of our deformations and execution happen in a single node. But in Maya, it's a first-class citizen, right? It's just another Maya deformer. And what's nice about this is that the puppeting system that you might have at your studio or you've built out over time, you can swap out the Maya deformers and bring in Ozone, right? So this means that 20 years of legacy and work and everything that may be done, you don't have to throw it all away. You can actually just adjust the glue layer between the two to drive these. And it's the same way in Unreal with Control Rig. And I'm teasing ahead. I'll show you some stuff at the end of the presentation there. But what this does is it unlocks some capabilities. So if I'm not beholden to the deformation system in any one environment, it means that I can be bringing different deformers to bear in the same system or in the same area. So let's just look at the joint here in the arm, right? So this is using Maya joints to drive Ozone's joint solver. Now what that allows us to do is some really cool things, right? So just thinking about joints in general, right? Typically, when I have my FB or my LR, right? You know, I've got my wrist joint. And then if I want to do twist, I have a series of joints in my arm, right, to average out that weighting because it's a normalized system. But with the joint solver, with Ozone's joint solver, I can have separate weights for my twist than I do for my FB and LR. So now I've got a single joint, and I can have different weights for different axes of rotation. So now my joint setup for my arm, instead of being, say, 9 joints, is only 3. Right? So even at the puppet level, we can remove complexity and still get complex art directable results on the back end. And if we look here, you know, just to make a point, like this shoulder, there are no blend shapes or corrects in this at all. That is pure weighting by being able to separate the twist from the FB and LR on it. So also this means, because while we can have our own deformers, we can expand your toolbox. So instead of getting your hammer and your slightly smaller hammer of a joint and a blend shape, we can actually open this up. So if I take this guy and I rotate it, right, I've got a joint on the head. But if I come to my little picker here and I grab the jaw and I open this up, right, this is actually a slide on a curve. So there are no joints in this area of the face. I'm actually driving this with a slide, and this is a different slide deformer. And I've layered them all together, and they play nicely with my, if I can hit the right key, because this is not my keyboard. Where are we, baby? Oh, I'm hitting the wrong button. Try this again, because it's a demo. It doesn't want to give me rotation rings. Well, whatever. It works with Translate too. So I'm not sure why my thing went away, because it's a demo and we're live. Yeah, my rotation just doesn't want to work. Okay. Whatever. Maya knows that I'm working on making it obsolete. Okay. So did I say that out loud in a recorded session? All right, so we have a joint here, right? But I also have a parametric bend on the tail. So instead of having to put a whole bunch of joints in there and averaging out all their weighting, I can use a parametric bend as a single deformer. And it all plays nicely with the rest of the system, right? So as I pull this up, right? So we start at the beginning, you work with less points because you can have sub-Ds. Flexible works anywhere. Here, because I can expand my toolbox, I can do more with less. I don't have to use just these 2 tools in my toolbox to solve the problem. And to take that to a crazy extreme, there are no joints or blend shapes in this. This is running live in Unreal 5. And you can see that we've got all kinds of really interesting shapes in motion, and none of it with joints, none of it with blend shapes. All this is done through a stack of deformers that have been all layered together with animated weights to create this animation, right? And to kind of come back here and kind of show you a little bit of how that works, let me come to there, I'll bring my picker up, okay? So let's check this out here. I'm gonna be mindful of my time. I'm gonna go really fast so people can ask questions, and if nobody has any questions, there's plenty more to show. So we'll, just so you know why I'm kind of banging through this. So we have this right here where I can roll this up, right? I can roll it, I can tighten, don't hit G4, whatever that is on the keyboard. Here, and I'll roll this in place, and then I can tighten this up here. And then because I'm dealing with nonlinear layer deformers, I can do stuff like this, where I can actually pull the carpet out and through, right? So, I mean, imagine trying to build this kind of system with joints and blends and how complicated that would be, right? And let's do this. And to kind of bring this home, I will come here, we'll add a ripple, right? And I can animate that ripple going through it. Now what's fun about this is you can see that it's not affecting the front of the carpet as I ripple this out. And as I roll this, I'm dynamically rolling it and subtracting the weight of the ripple. So my animators, as they're animating this, don't have to worry about that, right? With Ozone, you can dynamically change the weight of something that's deforming and animate that dynamic change in weight. So you can take a smaller toolbox, say we've got about 10 deformers that we're using right now, which will be infinite over time, but you can animate the weights of any one of them to get any number of effects on top of that, right? And we'll go here. So this is D. This is a character for our short film, Like, that will hopefully be released at the beginning of next year, early next year. And we're doing an event with AMD later this year. We're going to show off more of this. Let me bring up this guy here. All right. So let's look at this. Let me turn on wireframe. We'll get that eyes out of here. That, and we'll turn off locators. So this face rig here, right, as I pull and move these things up and down, again, there are no joints in this face. Everything you're seeing here are layered deformers with animated weights. So everything across this brow is a single deformer. It's a slide, right? All of the different minute controls over everything are by animating the weights of that one deformer together to create that shape and motion, right? So we can open up our eyes, right? We've got all the control that you might see in a feature rig where animators are going to tell you they want specific shapes and directors are going to want to give you those kind of notes and you have to hit them, right? So we can pull things up, pull things down. We've got nose we can pick up and down, left and right. So you can see just how kind of alive the whole face is. And this is because I can use independent weights. This means that my jaw up and down, right, is its own idea. So I can weight from the chin all the way up to the temple, and because I'm stacking, I'm adding these things together, I can think about each one broadly, and I can have my voice crack, and so I'll have a sip. All right, and then if we do this, we can guys together. Stop hitting G4 on this keyboard, right? Same idea. Moving things around, doing all kinds of fun stuff, full control, and everything you're seeing runs in real time in Engine. So if we look here, we've got a couple of animations that we've did, and we'll wait here. Come up, oops, because we're in a demo. All right. I'm not looking at, you're not seeing it because, there we go. So there's an animation. As you can see that we're driving this character again, real-time subds, we're really able to move the grooms with the Ozone asset. All of this was animated in Maya, brought in through our clip system, right? All this is running in real time. Ray trace shadows, all of it. So it's clear to me that, and I hope everybody in this room, right, that real time is the answer. This is where everything is headed. But there is this transition period we're in where people are moving from their current systems in here, and we like to call ourselves the gateway drug, right, where we can make it where you can use your existing systems and start taking full advantage of this new system, and as it matures, you'll be able to then fully embrace this and animate directly in Engine, because you'll be able to use Control Rig right with Ozone directly. Right. And then we'll finish off with our little guy here. But you can see just the expressiveness, the quality. This is the kind of thing you would expect in a feature kind of animation rig. And then to kind of bring this all the way to the, and one more thing, Jeremiah Grant, who's the head of rigging, or I forget his title, it's very long, but is in charge of a bunch of people and rigging at Epic. He was able to crack the nut for us. Up till now, we weren't able to get Control Rig to drive Ozone. He was able to help figure that out, and he built this, taking a metahuman face control to drive an Ozone rig, right? So this now is driving or using Control Rig, right, to drive an Ozone asset. So this means that when we get done with this, this next couple of weeks, we're going to be basically building a full Puppet so that you can animate these kind of deformers all live in engine using control rig. So for me, that's a really big deal. All right, I'm jamming through this really fast. Let me show one more here, just because it's fun. All right, this is a very big deal. This means uncompromised deformers, the kind of deformations you're used to in your feature or broadcast pipeline right in engine. So, all right, well, good. Actually, I moved pretty quickly. I'm actually going to show a little bit of the why this works. So let me also start off with, we'll watch this because it's way more fun to watch this animation than me tugging around on that. So currently Ozone is what I call a studio tool, or we're in pre-release. So we've engaged with several studios. The first project that's public was Supergiant Robot Brothers, done by Real Effects. That entire show used Ozone for all their characters. Now we've engaged with a bunch of studios since. I can't really talk about that because NDAs and all, but that's kind of the phase we're in. So currently we're developing a standalone Ozone Rig Studio tool to be able to then rig directly in that interface and then be able to bring your assets into Unreal and do weight painting and adjusting live. Because 90% of rigging is not building the systems, it's building the shapes and it's bringing your characters to life. So we're going to focus on those tools first. Then hopefully within the next year, we'll have a full standalone and anybody can have access to it. So right now, we're in a bit of a tease mode for you guys. Unless you're a studio and interested, and then we can talk. Because it does take, there are hoops you got to jump through to make it work. And I want to make sure that everybody succeeds, both clients and our product. So with that in mind, let me come here and I'm going to show you that currently we are authoring our systems in the Foundry's Modo. And that's because Modo is the only application on the market that natively supports a layered deformation idea. Then what we do is we take that and we convert it into Ozone scene description. And then that scene description, along with our execution engine, runs live in Unreal, Maya, and all the other applications we support. So I wanted to just kind of show a little bit of, like, why is this idea better? You know, why is order of operations, independent weights, like, why does this make a difference? So I'm going to walk through 3 little examples here of the why it's better. And then we'll talk about the rig library that's down here. And then I'll answer any questions you guys have. All right, so if we look at this is what I call the order of operations teapot. So we have a bend, right? So we can bend our little noodle here. We have a move, allow us to move it up and down, and we have a rotate that allows us to rotate. Let's turn this so it looks a little bit better, right? 3 deformers, three discrete ideas, all affecting this mesh in your scene. Now with changing no weighting or anything about the actual asset itself, and just changing the order in which these execute, I can get a very different effect. So let's take the move and say, I want the move to fire first. It always comes from the bottom. It starts at the leaves of the tree and moves down to the trunk. So now if I move this up, right, and then I bend it over, you'll see that it's changed the way it works. Because now the move is going through the bend space, right? It's moving, then it's bending. And it's all live, so as you change the position of the move, it appears like it's going through the bend space, right? And my rotate is still firing last, right? If I change my rotation and tell it to go first, and now I rotate, it's going to look like it's rolling inside that space as I'm adjusting my bend and I'm moving this element through. So right here should show how flexible this idea of a stack of ideas that add together versus a cloud of joints that really subtract from each other. And that's actually a big deal. Ozone and this way of working is an additive system versus the traditional joint and blend shape, which is a subtractive system. Okay? Now let's go to our next example. So this is an older version of Zoe, a different shape, but give you an idea of when we think about independent weights, right? Let me zoom this up here, right? So again, there are no blend shapes in this, right? This is all layered deformers. So as I'm opening the jaw here, I can look at my jaw weighting. You can see, I mentioned it before, right? We got all the weights at the bottom of the chin. It's rolling up to the temple. And that's one idea, the jaw open. As an artist, I get to concentrate on making that shape in motion look good. And then if I come here and I start thinking about lifting the mouth corner, I have this, right? I have separate weight for my mouth corner lift. And then here's the weighting for a mouth corner slide back, right? You see how the cheek reacts? That is a cheek deformer that allows me, and here's the domain of where this spatial deformer works, which allows me to slide this thing up under the surface. So all these pieces add together to create this final shape. Now, I think that alone is really powerful, being able to think about these as independent ideas, but there's more to this, because we all work, or most of us are either in production or want to be. We're going to get notes, we're going to get direction, we're going to have very specific shapes we need to hit. We have to account for what our VFX supervisor, animation supervisor, everybody wants. You want a system that makes it easier for you to make these changes. So what's nice about thinking about these as independent ideas, let's say I get a note, and I see many people in here. Let's say Mr. Sir Wade here gives me a note because he's an animator, and he goes, all right, Rich, I don't like this cheek. This cheek sucks. I'm like, all right, I'll fix it. So what I can do is I can turn off my jaw. I can turn off my mouth corner lift. It'll take a second to blow the cache there. Come on, baby, you can do it. And turn off the slide. And now I can look at this cheek deformer as an independent idea. Now I can make that change that Sir Wade has, hit it exactly right, and then turn my deformers back on and see how it all then reacts together. There's no free lunch, which means if I do these things in isolation, I have to make sure they all add together. But because it's an additive system, once I've done that work of polish, now I have a system that's also more robust than a joint-based system too. So just as a side note, the idea of being able to mute deformers is also part of our LOD kit. So in engine, if you have a full face rig, and everything firing, sorry, my voice is trash today. You can, as the character starts getting out of prominence, whether it's in frame or just falling back in the distance, you can mute dynamically in engine, mute these deformers, and give execution back to Unreal. So it has a lot of wins in it, including real time, right? So now I'm here and I'm like, cool. Now, animators always work right inside the range you tell them to, right? Rigging friends? Yeah, no, never. So we're constantly battling with animators want to pull and make big shapes because that's the performance. That's actually what they want and what the character needs, but it's difficult. So you end up in the traditional systems adding a correction on top of correction. It's this house of cards that you're fitting to try to hit 1,000 shapes that you manually fit together. And if somebody makes a change at the bottom of that stack, the whole card, it all falls apart. But this system here, where I have a handful of deformers that are adding together nice and cleanly, now I can do things like this. I can overdrive and pull the mouth corner up. I can slide it over, pull the mouth corner up, I can slide it over. Not a beautiful character, mind you, but it didn't break, and that's a big deal. Now my animators, using my rigs, can exaggerate and do things for performance that doesn't necessarily break the rig. I don't have to go back every single time and add another corrective on top of another corrective on top of another corrective. It's more robust, right? As well as one thing we can do is account for topology changes in the system. So now I can come in here and I can add a span to here, and my deformers haven't broken, right? So we also, on the topology side, can make changes to things after we've assembled and transferred our rigging over that's non-destructive, so that's cool too. All right, I think I'm on time here. Now let's go to this. So we looked at why is order of operations better? Why are independent weights and independent deformers better? Now let's talk about animated weights. So this is a little, I've been using this little guy forever as a little test. So let's go here and look at this. Okay. So here we have this little lip control. And you imagine this is a lip on a character's face, right? Which means that we've got this one control that does all of it, and then we've got these independent, left, mid, right, that all add together to create a shape. So under the hood, what's happening is this control, when I drive it, is actually wired into these individual controls, right? Now, in the traditional way, each one of these zones is a series of joints, right? You've got 1, 2, 3, 5, 10, whatever it is. You've got to build these different bells. You've got to balance all the weighting out and everything else. And then, again, if Sir Wade, the animator, destroyer of all rigging, comes in and says, make a change to my lip, yeah, you're here and I know you, so that's why I'm picking on you. Then you've got to go back and fix all of your corrections. You've got to fix all of your weighting to do that. But there is a better way to think about this, right? So let me bring up this here. So if we can think about these shapes as animated weights instead of, and I gotta stop hitting this freaking G5 key. You ever use a different keyboard you're not used to and you keep fumbling all over the place? Now imagine you're doing it in front of like 100 people. Okay, so here are these curves. These curves represent the carve-outs of these weights here. And these are live. So now if I get a note about how to change the shape of this bell, I can actually do it again here in my projection curves, right? And not have to do it at the joint and whatever skin weight level on the surface. Now, like everything, there's no free lunch. If I make this change, I have to make sure all the other curves balance out. But what's cool is, once you've done that work, you can save this bank of curves for different characters. So you can have different shape languages for different types of characters and just swap out the curves and not have to change your weighting on the rig at all. It all happens in real time. So everything we're seeing here will run in real time in Engine, right? So if we look at this now, and we go here, I pull this up, you'll also notice that we have a little shape here. So I hate on blend shapes to make a point, but of course we're going to want to be able to use them where they're the most valuable, right? So we certainly support blend shapes as a deformer type, but it is a first-class citizen. It's not, like joints and blend shapes one before the other. It's like you can use a blend shape anywhere in our stack that you want. Now in this case, I've added this little volume here. Well, because it is a standard or a deformer like any other deformer, I can carve the weight of my shape corrections or my blend shapes at the same time. So that means when I come up here, you'll notice that this is coming up here and then fading off along the side. If I take this curve and I stretch it out, you'll see that the blend shape's being brought in at the same time that I'm changing that. So again, for my rigging TD friends, now if I need to make a shape for this, I can pull it all the way up, do one blend, and I'm done. If I get a note from my animator to make a change to the bell, it all happens dynamically. I don't have to fix a weight on a joint. I don't have to change a sculpt at all. You think about the time that saves. Think about a hand on a character. Every time we're fighting with the fact that the knuckle is way farther in the hand than you think, right? When you do this, you've got to deal with all this mass under here and every interaction between every finger. With animated weights, you can do this, you can do one sculpt, and you're done. Just think about that times 1,000 characters that you have to build, or the same thing over and over again. This kind of stuff saves huge amounts of time and money in a production, and it's just a small part of how this thing works. So then let's go into fun land with this, because we can do that. I have 20 minutes, and you're going to poke at me about the time. I say in jest. We can do things that are a lot of fun, too. So we can do this, and then we can start animating the shapes of these gradient curves. We can slide them around, right? And we can do wacky stuff like this, where we can add an amplitude, adjust the frequency, right? And then start sliding this around. Because this is just another effect that's layered into the rest of my deformers, I can come up here and get the wrong one. This guy, there we go. So now I can open the mouth, lower the mouth, lift the corner, and all of my deformers still work. And again, think about how you would do this with a joint system. This is 8 rotates. That's it, right? And I can change it, tweak it, add new deformer effects, and whatever I want on the way. So anyway, that's basically the breakdown of where we're doing things. I did want to mention this at the end, and then we'll have 20 minutes for questions, which is what I wanted. Otherwise, I will dig in and do other things. But part of our mission with Ozone Rig Studio is not just to create a great tool that has great capabilities. For people who haven't had the experience I've had, and I guess I didn't mention at the beginning, I spent 13 years at Pixar. I worked at Rhythm and Hughes before then. I've been rigging for 20 years. Not everybody has that experience or will have that experience, but they would love to make great characters. So one of our missions is to create a library of rigs so that you don't have to invent the system yourself. You can just use it. Now, all of these, you can crack them open and learn from it and build your own, but we will be literally delivering a character pipeline in a box, which means that if you want to build a biped character, we're going to have examples, weighted, fully working examples that you can use, reuse. All these rigs will become a part of it, and anything you build in Rig Studio will run in any application that we support Unreal being the largest of the bunch there.